most organizations, a functional layout is established. Functional layouts are by far the most common layout you will find in organizations. These layouts can be seen in how machines and people are positioned. A functional layout is a workspace configuration in which operations and processes are organized by the type of work or function that they do. In these functional layouts, people are trained to perform work on one machine and one machine only. As you can see in the example, drill presses are all together. Assembly is together. Inventory and milling machines are all placed together. While these functional layouts may be easy to set up, they take no regard for the sequence of operations. In other words, the process to manufacture an item is a bit chaotic. In this circumstance, you need to first understand the current process or flow of production. In the example, you see a layout of the plant is drawn and arrows guide the flow of production. Numbers are used to identify the answers to the following questions. Where does the process begin? And where does the process end? This is a very simplified way that you can establish a very basic spaghetti diagram. Now let's stretch your mind a bit. In the upcoming assignment or comments section of this module, it's your turn to choose a production process in your place of work. Once you've selected a process, then you can answer the following questions. First, what is the total distance that someone would have to travel in between operations through the entire process? You can find this by walking the flow of the process. Next, how much is the total time of that distance traveled? And finally, what is the total time of the entire process? We look forward to reading your answers, and we'll see you in the next module. In the pullet stages, phase 2 is to co-locate the equipment according to the process sequence. This is where you move equipment into a sequential layout according to the flow of your production process. One challenge that you may run into is moving what are known as large monuments. Monuments are large, difficult, and specialized machinery that is tough to reorganize. If you run into this situation, you'll want to move the smaller pieces of equipment around the monuments according to the process flow. This will allow you to avoid the struggle of hiring and moving these machines and take full advantage of the machines for processes that may use batch manufacturing. In these cases, you can build cells around the monuments. Once you have moved your functional layout into a process-based layout, you will have a great reduction in the distance traveled as well as the production times. One other benefit of co-locating your equipment in a sequence is that it makes it much easier to see work in process inventory build up, which will help you remove inventory waste later on. Now, before we go, we'd like to give you a few questions that you can answer in the comments section or the upcoming assignments section of this module. Firstly, do you have any large monuments or machines that are part of a process that you cannot move? And then, can you move equipment anywhere you want, or would you need to plan a Kaizen event to change your layouts from a functional layout to a process-based layout? Remember, these questions are meant to get you thinking about actionable items as well as give you feedback. We look forward to hearing from you, and we'll see you in the next module. After all your equipment has been co-located and placed in the order of your production flow, you can now maximize the benefits of your co-location by placing your equipment into a cell. Cellular layouts are the optimal flow-based layout. A cell is a close arrangement or setup of people, machines, or workstations. The purpose of a cellular layout is to fulfill a processing sequence while simultaneously reducing wait times, transportation, and other forms of muda. Cells can be difficult to set up and may require you to schedule a Kaizen event to make the adjustments. This is why you should co-locate the equipment according to sequence before designing a cell. In some cases, however, an office, for example, may not need to co-locate items because you mainly move computers, desks, and other lighter items, whereas a shop floor that has monuments would need to be co-located before building your cell. Keep in mind, there are many different types of cells that can be built. With this in mind, in the next 3 modules, we will discuss 3 important aspects of your designing of cells. Those are sequence, cell shapes, and point of use placement. We'll see you in the next module. Organizing equipment and information according to work sequence places things in order, and not only will it reduce forms of waste in your cells, it will also expose other forms of waste too. For example, when you place your equipment in a sequential order, work in process inventory cannot be stacked up in extreme amounts, which means that over time your inventory level should go down. In addition to this benefit, you will greatly reduce transportation distances in comparison to a functional layout. With this in mind, it will also expose many opportunities for you. For example, if a machine breaks down, you will know right away. When a machine goes idle, you will see the issue right away, and you can get it fixed as soon as possible. Another opportunity that will become obvious when equipment is co-located and placed in sequence is that you will need to balance the work that is performed on the line. This is referred to as line balancing. As you can tell, the benefits of moving from a functional-based layout far exceed any challenges that you might be presented with. Lead times will go down, floor space will be freed up, and WIP inventory will be reduced, which ultimately frees up cash flow for your organization. There is one more benefit that we feel we should mention too, and that is the benefit that directly relates to people. When operators work in cells, they gain first-hand experience of detail within the cell and the entire process. Oftentimes they see small details that add up to great opportunities to improve and make work easier. As operators identify forms of waste and issues within the cell they are working in, they can share ideas and brainstorm how they can improve their lines. You will see that after your cells are established, operators who work in the cells will develop a great sense of pride for their cell. And that's it. The basics of work sequence. A work cell is commonly thought of as a U-shaped or C-shaped cell. Truthfully speaking, though, they can be designed in a variety of ways to fit your specific needs. One important thing to remember is that the cells should not be designed in a mini functional layout. They need to be organized by the flow of your process. This will ensure that the cell is process-based and not operational-based. While there are many different shapes, cells are most commonly organized in straight line, I-shaped layouts, L-shaped layouts, U-shaped layouts, C-shaped layouts, and sometimes even S-shaped layouts. Some things to keep in mind when designing your cells are what size are your equipment, what is the shape of the equipment, is the item in constant production or not, and is the material used on the cell difficult to move. Cells should be able to flow freely upstream and downstream, and workers should be trained on the entire cell. While cells may require a Kaizen event to set up, they will also yield some massive advantages. Some of those advantages include walking distance and transportation muda are reduced, work in process is reduced, the communication of people increases, line balancing of the cell, and the entire value stream becomes much easier and lead times drastically go down. Keep these benefits in mind as you build your cells, and we'll see you in the next lecture. One of the purposes of a cell is that the process flow is all set close together. This reduces transportation and motion waste within the cell. This close together placement is referred to as point of use placement. Each of the operations within the cell should be placed as close together as possible, so that all forms of muda are minimized and the cell is already in a position to transform from Kanban to one-piece flow. As you begin to establish your cell design, you will see that lead times will be drastically reduced, as well as forms of motion like reaching, bending, lifting, stretching, twisting, and other dangerous movements. This reassures that the cell is not only a superior design compared to its functional counterpart, and that it is safer as well. One activity that can really help maximize your point of use design is 5S. The 5S system should be in place to save space, keep things organized, and reveal waste as well as opportunities to improve. One last thing before we move on. As you place your operations in a process flow layout within a cell, be sure that all needed supplies, materials, tools, and equipment are within the operator's reach. They should also follow the production flow of the materials or information so that they can flow in and out very smoothly. And that's it. Point of use placement within a cell.